We are going to go through the evens today, the odds tomorrow, and as I was just saying a minute ago, use the tools, which would be the videos, the homework, the notes, all those different types of things, and actually practice some of this, because if you practice, you're going to be better at it and you're going to be quicker at it. Calculator always is a good idea as a backup plan, especially when we get to fractions, graphing, things like that. And colors for the graphs when we're doing shifts is a good idea too. So, excuse me. With that in mind, let me move a couple of things out of the way here. So, all right, we get to the top here. Simplify, your answer should only contain positive exponents. I'm trying to give a hint here. So some of you, bless you, that you don't end up putting a bunch of negative exponents in places and then going, oh. So we're going to start here at 2. And again, our general rules here, and we'll do a little general go over with our rules here. When we're looking at these, and we've talked a little bit about this before, thank you, is that whenever I have parentheses, I'm going to do that first. So, I say parentheses. I also need to remind myself, if something doesn't have an exponent, it's a 1. Excuse me. Because that exponent outside the parentheses works its way all the way through. And again, when we go power to power, we're multiplying exponents. So 1 times negative 4 would be negative 4. Negative 2 times negative 4 would be positive 8. 2 times negative 4 would be negative 8. And then we'll just write that x to the negative 1 in there, because nothing really happened yet. Hey, step 1, good. No more parentheses. Step 2. We're going to deal with the negative exponents. Remember, we flip them. So if it doesn't look like a fraction right away, we're going to make it look like 1. Because now I'm just going to go term by term, and if I see something that has a negative exponent, I'm going to flip it, and that makes the exponent positive. If it doesn't have a negative exponent, I'm not touching it. I'm leaving it right where it's at. Negative exponent, flip. Negative exponent, flip. Because that's been one of our Achilles heels. We do a lot of this stuff well, and then all of a sudden we try to do things with negative exponents when we don't need to. Now I get to my multiplying, which is adding the exponents, or dividing, which is subtracting. So I'm going to deal with my variable terms first. I'll deal with this number in a minute. So I look and I go, okay, well, I notice y, there's no other y's. So y, I'm just going to leave it alone. But the x's, I notice I've got 1 in the numerator and 1 in the denominator. So I'm dividing them. I need to subtract the exponents. Bigger minus smaller. 8 minus 1 is 7. And wherever the bigger exponent is, that's where my answer goes. Now, when it comes to this, okay, coefficients don't have the same rules as my variable terms do, okay? 2 to the 4th is 2 to the 4th. And I'm going to even write this to stress this to some of you. 2 to the 4th power does not equal 8. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. And if you're not sure, use the calculator. Okay? But since that's not a negative exponent, it stays right where it's at. And if I did have a number up top, we'd work on that. But as you can see in part 2 of the video, we'll be having one of those that we're going to deal with. Okay? But if you want to try and deal with it on your own, you can. So that's one thing to keep in mind. When we get to the next part, okay, simplify. Your answer should only contain positive exponents. Now this is a little more interesting. So the first thing I notice, okay, there's no parentheses. That's a good thing. There's no negative exponents. That's a good thing. Probably should bring this down where you can actually see it. Okay. These, though, are coefficients. 3 times 2 is 6. Okay, they work just like regular numbers. When I look at my u's, I notice I have u to the 3/4 plus 1/2, because when we multiply, we add. And I've also got v, bless you, to the 1/2 plus 1/3. Now, I'm going to be realistic here, okay? We're not going to have, we need a common denominator. So on that u term, that's not just going to be 4/6. Can't do that. Wish it was that easy, but it's not. So what we're going to do instead is you either need to find a common denominator, or what we could do that's even easier, and again, there's nothing wrong with it. You got to use the tools, and that's what we were talking about before, is pull out a calculator if you need to. Use parentheses with your fractions. Do not write 1.25 as your exponent, though. Math, enter, enter. Okay? There is nothing wrong with you letting the calculator help with the fractions. And again, doing it with the 1/2 plus 1/3. Again, if you know the common denominator is 6 and you want to build them, I say more power to you. We do not do decimals. Math, enter, enter. All my exponents are positive, and I'm okay. And again, when we get a little bit further, when we get to tomorrow's, we'll discuss that a little bit more in detail. All right, 6. Write each expression in radical form. Okay, we need a reminder here. When I see something in exponent form like this is my exponent, this little number on the bottom is my root. So when I go to write this in radical form, whatever's in the parentheses, or whatever my base is, goes underneath the radical. So on number 7 tomorrow, it'll be b that goes under there. The number on top of my fraction is my exponent. The number in the denominator is my root. That's it. Nothing to simplify, nothing to reduce, nothing to fix, nothing to calculate, just rewriting it. Okay, and remembering that exponent over root. And the nice thing is, once I get this one done, and then I've got it done right, when I get to number 8, we're just doing the opposite. Because here is my exponent. Here's my root. And we just got done seeing that when I do it in its exponent form, whatever's under the radical goes in the parentheses. And then exponent over root. Exponent over root. And I'm good. But again, I got to keep those straight. And I always tell myself, hey, E comes before R in the alphabet, so it does too when I'm making my fraction. Just a little hint. All right, here comes our other buddy. Factoring. Good times. Okay? When we get to the factoring portion of this, again, I've got my tan sheet that I can use. I'm not going to refer to it here again in here because, at this point we've talked about it a lot. But I'm always going to look first. I'm going to do my golden rule, which again is there anything in common? It can be a number that divides into all three. It can be a variable that they all have in common, but sometimes there may not be anything. But you do need to check. So here I'm like, well, these both have x. No, that doesn't. No number. No, I can't do anything. Okay. So in that case, I'm looking for two numbers that multiply to get the number on the end and add to get the number in the middle. So I noticed some things. First thing I notice is my multiply number is negative. Which means what? Which means one of my signs is positive and one of them is negative. At this point, I can go to my multiplication chart. I can go to a calculator. Shoot, if I know my factors and can multiply to 56 in my head, that's the best case scenario. So I would think that with a lot of you, when you get to 56, the only thing that's going to probably pop into your head is 8 and 7. Now that's fortunate for us. You're like, well, 8 and 7 don't add up to 1. No, but one of them has to be negative, and it would be the bigger number. Negative 8 times 7 is a negative 56. Negative 8 plus 7 is negative 1. That works. Now, it won't always work on the first one, and we're going to see that here momentarily. But again, calculator, chart, whatever you got to do, okay, to get that value in there. All right, let's see what else we got to play with here. Oh, more factoring. All right. Again, golden rule always comes first. You're like, wait a minute. 5 and 35. Huh. I can divide 5 into both of those. Now, let's say that's the only thing you see. Even though there's more, but let's say that's all you see. So you go, you make your parentheses. And you're like, well, 5 divided by 5 is 1. So I can put v squared, or if I want to put a 1v squared, I could. And you're like, 35 divided by 5 is 7v. Now, before you circle it, let's look at something for a minute. I look inside the parentheses, and I notice there's still something they have in common. These both have a v. Uh-oh. Well, now what can I do? I can still do it here. I can take one of the v's out. Now, hopefully, you'll see this right away in future problems. You won't have to do that. So what's that mean? Well, I took one v out, and they add 2. So now I got 1 left. If I want to put the 1, I can. Because v times v is v squared. And here, I already have the v. So the only thing that's left is the 7. So this is one of those type of questions. If it's a test question, if you got to this step, you'd get 1 point out of the 2. If you get to this step, you get both. Okay? Because if there's something that they have in common, we got to get all of it. And that's the only way that's going to work. 14. 3, 23, and 14. I can try all I want. Nothing's divided into all of those. I have m's in the first two. I do not have an m in the third. So this time, for a majority of you, we're either going to guess and check, or we're going to slide and divide. So what I'm going to do, again, I want to be able to show both things. So I'm going to do the guess and check here, and then we'll see. Maybe we'll need slide and divide down here. I'm not sure. So you're like, okay, I would guess and check work. Well, how many ways can I multiply to get 3? Not many. 3 and 1. So I'd write those down. But now, I've got this 14 here. So that could be 2 and 7. It could be 1 and 14. So either I use a pencil, and I start plugging in numbers, trying to see what one works. Or maybe you just kind of do it with your fingers. So maybe you go, okay, 1 add up to 23. So this would be 6, because 3 times 2 is 6. 1 times 7 is 7. 6 and 7 does not get me to 23. Well, what if I flip? 1 times 2 is 2. 3 times 7 is 21. Ooh. 2 plus 21 is 23. So I want the 3 to go with the 7. Remember, it's always going to be the middle ones go together in the outer. So if I want the 3 to go with 7, 7 goes out here. 2 would go here. 2m and 21m is 23. 2 times 7 is 14. Boom. I got that one. Okay. So that's a legit way to go about it, especially if you're comfortable with your multiplication facts. Now, if you're not, all is not lost. We still have another option, but be careful. Because I know how some of you are looking at these too now. Some of you are looking at this going, okay, so 6. So let me see if 6 goes in. And you try that, you go, nope, nothing goes in. I go to slide and divide. It's not always going to be that first number that they all have in common. It might be smaller. Like, for instance, what can I multiply to get 6? Those are numbers that could divide in. So what if I try 3? Well, 6 divided by 3, yeah, that works. Does 3 go into 39? Ooh. 3 go into 45? Yes. So 3 is the common factor here. So 6 divided by 3 we saw is 2. Goes with my a squared. 39 divided by 3 is 13. That goes with my a. And 45 divided by 3 is 15. Now, did that fix all the world's problems? No. I still have a coefficient in front of my 2. So, now we'll do slide divider. If you're a guess and checker, you can do guess and check here. But only with the stuff that's inside the parentheses for the moment. So we'll swing that guy down to the end, and I'm going to do my work over here. So we're going to have a squared plus 13a plus 30, because 2 times 15, and we slide it down. And now it's like a diamond. We're multiplying to get the number on the end. We're adding to get the number in the middle. So I start looking at this, and I'm like, okay, 30, 6, and 5. Well, 6 plus 5 is 11. That didn't work. Well, I don't know what else multiplies to get 30. Okay, go to your calculator. There you go. Maybe you try 30 and 1. You're like, oh, that didn't add up. Then you try 2, and you get 2 and 15. You're like, dang, this is never going to end. Keep going. You're almost there. 30 divided by 3 is 10. Add those up. Oh, there it is. And here's the other spot some of you have run into dilemmas on. We're going to avoid this. That is not the factored form of what I want it to end. Okay? We did the slide. I've still got to do the divide part. So at this point, remember that 3 that was there? It's still part of my answer. If the 2 goes in nicely, 10 divided by 2 is 5. Okay, so that one was nice. But here, if you're not sure and you punch it in your calculator and you get a decimal, and you hit math, enter, and it's a fraction, that's okay. But you don't leave it that way. You bring that back to the front. And I'm done. Okay? So, I mean, you've got several steps to play with there, and that can happen sometimes. But that's what we're going to look at. Okay? More factoring coming tomorrow. But again, I would use these and try those other couple on my own to see if I'm starting to catch on here or not. Right here in the box. You would... Okay, well, a couple of things there. If you, did you not take out a 3 at the beginning, or did you get something else when you took the 3 out?
I took out the 3, and then I did slide in the line, but I didn't use parentheses.
So what did you end up with?
I got a plus 5 thirds and a plus 1 third. A plus 10 and a plus 3 and then
But it's not 6. We took the 3 out at the beginning. It's only what's in the parentheses is what we're using there.
I didn't use parentheses, so I did 6 divided by 3.
Okay. Okay, good question. So what if I forgot to take the 6 out? Here's what it would come down to. When you got to the end then, and you got all your parentheses put back into place, so what did you end up with our final answer? You've got, yeah, but we're not going to have fractions. Once you slide that denominator back, so if you had 5 thirds, that'd be 3a plus 5. And then what was your other one?
1/2.
Okay. So that would be 2a plus 1. Now here's the dilemma you ended up with. If I FOIL that out, and again, this is where if I didn't take the 3 out at the beginning, let's see what happens. So I've got my 6a squared. Okay, that's okay so far. Now the fun's going to start. Plus 10a plus 3a plus 5. What's going to end up happening is you're not going to end up back at the same place. So you've really got to look, or sometimes even you can end up at the same place here, but you may see a common factor show up here that you get to the end and maybe this was 2a plus 4. Oh, crap, I can still take something out. So really try to remember to take that first value out when you're doing these, because otherwise it can get to be a little bit troublesome otherwise. But if that was one of the things where it foils outright still, it would be a little deduction because it's not quite simplified completely, but it still would be better than nothing. All right, graphing equations. Tell the vertex, domain, and range. Lots of things we can take from this. So when we're doing these, and you're going to see this pattern show up over and over with these. So when I'm doing this, my vertex is h and k. So if that's the case, my vertex on this one, remember this is the opposite of h, so the opposite of 2 would be negative 2. And we keep this guy out here. So negative 2, 1 would be my vertex. Once I have that, I look at my a value. And my a value is going to tell me two things. It's going to tell me, is my graph going to open up or down? Well, negative means it's going to open down. And remember, with absolute value equations, it's a V. It is not just a line. And that's why we call this A our air quote slope. Because I am going to go down 2 and over 1, but I'm going to do it in both directions, both left and right. Because I should get this thing that looks like a triangle or a V. And if I want to make one more set of points, I can go down 2 and over 1 more time. And connect my dots. Okay. That's how I can get my graph. But, and I'm going to stress this a lot over these 2 days, read the directions and make sure you give me everything. There's our vertex. I still need domain and range. So when I do domain and range, x values left to right. Cool thing with absolute value graphs, your domain is going to be the same every single problem, no matter what. Forever left, forever right. Infinite. Okay, so that's always the same. My range, my y values, from bottom to top, goes down forever in this case. May not always be true. And then goes up to here. Remember, y value, take it back to the y-axis, which is going to be at 1. And I'm set there. Okay, so there's lots of little clues, both visual and otherwise. But again, I've got to pay attention to that. But V, gotta have them on those. All right, so then we get to 20. Notice it's not absolute value anymore. Sketch the graph, name the domain and range. Okay, a couple things to remember here. This should look really familiar for some reason. It looks exactly the same as absolute value did, except now it's a radical instead of an absolute value. And we use the values a little bit differently. Because with these, we think more about shifts in our parent graphs. So remember, that is my left and right shift, whatever's going on under the radical. And it's the opposite of what we would think. My K is my up and down. So when I go to do these, I have options. I can punch it in on the calculator, but I'm not going to because that's the slower way. When we're doing these, I've been barking at this. My voice about sounds like it. When we have a square root, and you've got to watch to see if it's square or cubed. I'm going to use my perfect squares as my parent points. So I'm using these because they're perfect squares and they're on your tan sheet as well, if you forget. And then the square root of those values perform this. Now, if there were a number in front, we're going to see that number 22, I'd have one more column, but I don't here. Okay? I'm graphing this with my parent points. So, I'm going to plot those points little. Now, sometimes we may have a little bit of a tricky time fitting them all in there. And that's life. So now, once I have those, now I look to see if I have any shifts. And I see I have a +3 underneath, which means left. And this is where the colors can come in handy. If I'm going to go left 3, I take each of those parent points, and I'm going to move them left 3. And that is my actual graph. That's the only one where I want to connect the dots. But again, I'm not quite done. Name the domain and range. Okay, here comes the connection. Domain. X values left to right. Normally, my domain on a parent graph starts at 0 and goes to infinity. But I moved left 3. So my furthest value of x to the left is at -3. So any left or right shift is going to go along with this. My y value at that starting point is 0. Why? Because there was no up or down shift. If there's no up or down shift, it's going to be at 0 every time. So there's a lot of things to connect, but again, the only way you make those connections is by practicing so it becomes irregular to you. Because really the only thing that's going to be different when I get to 22 here in a moment is going to be now that I've got a value out in front. So what's that mean? Well, what that means, my parent x points aren't going to change. Second column, not going to change. The issue here is we're going to have a third column because of that number in front. And notice I put 2y, which means I'm going to multiply all my y values by 2. So 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Those are my parent points. My new y values, but the x values stay the same. So I'm at 0, 0. Again, kind of little. We want to be able to see them, but at the same time, we want to know that we still have our shifting to do. I look under here. Minus under the radical is right, which is going to make this graph kind of interesting here, I can see. So move each of these to the right. I'm not quite sure how this is going to end up for me, but a little off the graph there to say the least, but hey, that happens sometimes. So again, when I'm doing domain and range, normally it starts at 0 unless there's a shift. Right shift, that's on my x-axis. My domain starts at 4. Okay, my range, I didn't move up or down. This point is still sitting at 0. And I go about my business. So that's what we're looking at as far as that goes. But again, the only way it gets better is with practice. They're like, woof, the test isn't going to be this long, is it? No, no, it is not. All right, solve on the graphing calculator. Isolate your radicals first. What's that mean? It means if I have a radical and there's stuff going on that side that's outside of it, that needs to go away. once I get here, bust out the handy dandy graphing calculator. And each side of it, again, it's second and x squared to get your radical. Doesn't hurt to take a peek. Whoa, wow, my window is off. Hang on just a moment here. Holy macaroni. Oh dear. Hang on one moment. Greatest thing ever, except when you're in the middle of a video and everything goes haywire, because people like to spend more time messing around with these things than they do actually getting their work done. All right, let's try this again. Little reset's not stopping me. All right, so there goes my 4. Here comes my radical. I see they cross. Okay, so there's a couple of ways I could do this. One way is to pull up the chart, and what I'm going to do is I'm going to go to my y's, and I'm going to look to see where the y's are the same. And I should find, and I find them. Okay, that does not mean the answer is 4. The answer is the x value where your y's are the same. If you want to write n instead of x, I understand. But look, and sometimes you may have 2. That's why I like to look at the graph first. It only looked like there was 1, but maybe there will be 2. And that's how I'd find that answer. That's it. If you moved the 2, you'd have everything on this side. So I guess your first line would be 0. And then over here, you'd have the square root of 1 minus 5n minus 4. There's so many things that can go wrong with that. If some of you want to go rogue and do your own thing, you can. Yeah, whatever is not a radical on the side where the radical is. Like if there's one radical on each side, like 23, which we're going to see tomorrow, that's fine. Or like here, the radical's alone, that one's ready to go. But if there's something hanging out on the outside or multiplying in front, that really needs to go away first. Yep. All right. Now circles, the new stuff. Circles, again, reminder. And when we're going to make this form, the 3 values that I need to know are h, k, and r. And I have all 3 of those. Because my center gives me h and k, and the radius is right there. So to be honest, when people are doing this, the place where there tends to be the most issue usually doesn't come until the radius, surprisingly enough. X, opposite of h. Remember your squareds. Y, opposite of k. Bless you. But remember, this is radius squared. Do not leave it that way. I want to know if you know your math. And here you're going to get lucky, because whether you did 2 squared or 2 times 2, you're going to end up with the same thing. That will not happen every time. And if you're worried you're going to forget the form, don't, because think about it. The form's in the next section. So if you get to this part and you're like, crap, I forgot what the form is, look down here and hopefully it gives you a pretty good reminder of what that's going to look like. But that's all I have to do up there. Just get that set like that. So I keep rolling. Identify the center and radius. Okay, again, the center is just taking the opposites of both of these. Opposite of -4 is 4. Opposite of 2 is -2. So I plot that point. And then remember, this is my radius squared. So if r squared equals 4, I just take the square root of whatever that value is. The square root of 4 is 2. And like we did before, to make the circle, I'm going to go 2 up, 2 left, 2 down, 2 right. And then do my best job to make it look like a circle. But I've got to take that square root there. If I forget that, I'm kind of off. All right. What you got left, Harty? Oh, dear. Our all-time favorites. All right. Piecewise. Colors. Colors with a reminder. Oops. Need to be on the screen, Harty. All right. I can't stress this enough. Your line starts where that inequality is. Your line on this one starts at x equals 1. And for most of you, we've had a chat about this. If you make yourself a little chart and put your 1 there, I've got to understand what this inequality arrow means. This says x is less than or equal to 1. Less than goes left. So 0 and negative 1 would be my next two values that I'd plug in. Since it's or equal to, maybe a filled in dot. So once I have that, now I can do one of two things. These are simple enough, you need to be able to do these in your head. I mean, 1 minus 3, negative 2. 0 minus 3, I'm just plugging it into the expression. Negative 1 minus 3. Those are the 3 points I'm going to plot. So I start at 1, negative 2 with a big dot. It's colored in. 0, negative 3, negative 1, negative 4. Start at the big dot. Okay, line starts here. Connect the dots. Same concept for the second one. Make me a little chart. Where am I starting? Still starting at 1. But it's just greater than. Open circle. X is greater than 1. Greater goes to the right on a number line. Make a number line if you need to. 2, 3. Plug them in. 2 times 1 is 2. 2 times 2 is 4. 3 times 2 is 6. 1, 2. Open circle. 2, 4. 3, 6. Big dot. Connect the dots. Okay. The graphing part's done. For the algebra part, you have choices. If you made charts, f of 0. When x is 0, what does y equal? Negative 3. If you don't want to do it that way, which one of the inequalities does 0 true for? Is 0 less than 1? Yeah. 0 minus 3 is negative 3. 1. Is 1 less than 1? No. Is 1 equal to 1? Yes. 1 minus 3 is negative 2. What about when it's 2? Look at my chart and see that it's 4. Or, is 2 less than 1? No. Is 2 greater than 1? Yes. 2 times 2 is 4. I get it that way. Okay, so a little algebra, a little bit of that. I'm going to time this out just about right. So the last couple. Domain and range of graphs. And is it a function? Remember, function. Vertical line test. Can I run a vertical line through and it only goes through my graph at one point? If that answer is yes, we put yes. If it's not true, if it goes through it more, we put no. Domain. X values. Left to furthest right. 3. Range. Y value. Bottom. Again, going to the y-axis. 1 to the top point. Y value. 3. 34, same deal. 1 point, looking good. Okay. Domain. Left. 2, 3, 4, negative 4. to right. And again, notice even with the colors I'm doing this, you can do that. Shoot, it's your test. You mark all over it. Range, bottom, -2, to top, 4. Okay. Even though we'll discuss the odds tomorrow, try some of them now that you have an example. See if you can do it. Because again, if you just say, feed me, you're going to be in trouble when you got to go find your own food on the test, okay? So work on that. We'll finish up that rest